Hello. So today I'll be talking about the effect of precipitation on the prevalence of Aedes aegypti mosquitoes. So Aedes aegypti mosquitoes are a primary vector associated with the transmission of dengue fever and are most commonly present in tropical and subtropical areas of the world. Like most mosquitoes, Aedes aegypti populations are heavily influenced by three variable abiotic factors set aside by Dickens et al. These factors are temperature, moisture availability, and man-made disturbances. For this presentation, we will be focusing on precipitation and moisture availability, knowing that moisture availability is a crucial factor in vector population sizes and prevalence. I hypothesize that an increase in precipitation will lead to an increase in Aedes aegypti population size, as increased moisture provides ample habitat and conditions needed for larval success. I predict that if my hypothesis is to be supported, we will observe an increase in the prevalence of Aedes aegypti populations during the years with higher mean precipitation, shown visually by a regression table with a high R-squared value and close points to the line. To test this hypothesis, I conducted research through the Google Scholar database to find information on the prevalence of Aedes mosquito outbreaks in the Pacific, finding such information from the years 1910 to 2020 in 5 years intervals from Sok et al., as well as finding information on precipitation trends in the same area, where I used the mean precipitation for the month of January in the country of Fiji, an area known for its dengue outbreaks, on a scale from 10 years from the CCKP. I combined these two data sets on an Excel spreadsheet, adjusting the information to fit the same timescale, and ran a linear regression analysis to determine the causal relationship of precipitation on Aedes aegypti outbreaks. By analyzing the results of the linear regression set in front of us, I was able to determine that the strength of the relationship and the reliability of the linear regression were both weak, with an R-squared value of 0.0117 and a p-value of 0.82, meaning that the data collected had no significant cause and effect relationship, where an increase in precipitation was not found to increase the prevalence of Aedes aegypti outbreaks. Although we were able to conclude that precipitation did not have a strong causal effect on the prevalence of Aedes aegypti in Pacific regions, as we hypothesized, we are still able to infer that precipitation plays some role in regional outbreaks, as the R-squared value was not zero. By having this knowledge, we were able to consider other factors that could have a larger impact on populations of this vector species, such as temperature and man-made disturbances, both of which are also considered to be heavily influential in Aedes aegypti numbers. Continuing to study this topic is extremely important, allowing us to predict population numbers and hopefully prevent large outbreaks of vector-borne illness, such as dengue fever. And that is all I have to say. Goodbye.